Hi everyone, today we're going to go through some of the statistics for Year 9, and in this we're going to cover mean, median, mode, range. We're going to go through frequency distribution tables, have a look at histograms, and a few other little bits and pieces. So the first thing we're going to go and have a look at is reading the range and the spread and the centre of data, which you've probably seen before. We can find the mean, median, mode and range. So we're going to go through them we're going to go through them one at a time, and we're going to use this little poem here to kind of guide us. So this is something I teach my Year 7s, and it's just hey diddle, the median's the middle, you add and divide for the mean, the mode is the one that you see the most, and the range is the difference between. So it kind of tells you which one's which and what you have to do. So we're going to start at the start there. We're going to start with median, and I'm going to try and colour coordinate it. So the median's the middle, but you've got to think the middle of what? So the median only works if your data is in order. So we're going to put it in order, and we're going to put it in order from least to greatest. You can go greatest to least. It doesn't really matter because you're trying to find the middle. So I'm going to look at my data. My smallest is a 2, so I'm going to put, I've got 2, I've got 1, 2 more 2s. Okay, so this is what you would do. Oh, my pen's going crazy. This is what you would do on an assignment or a test. You go off and you cross them off as you go. So I put 2 3s in, put another 2 3s in. There's another 3 there. Okay, I'm all out of 3s. Now I'm going to go to 4. So I've got 1, 2, 3, 4s over there. I'm going to cross them off as I go. Got 1, 2, got another 3. 1, 2, 3. 1, 2, 3, and I've got another 3 there. 1, 2, 3. Now you're going to try and keep this all on one page. I have not succeeded with that, but we want them in order more than anything. So 4s look like they're all done. I'm going to go through 5s. I've got 1, 2, 3 5s. 1, 2, 3 5s. 1, 2, 3. 1, 2, 3 more. 1, 2, 3. 1, 2, 3, and I've got another one over there. Okay, 6s, 1, 2, 3, 4 6s, 1, 2, 3, 4 6s, 1, 2, 3, 4, 7, and an 8. Okay, so I've got all my data in order, and I'm going to go through and count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And the question asked me for 30 pieces of data, so I know I've got them all. So the median is going to be the middle of these data pieces put in order. So if you think we've got 30 data pieces, it's going to be between the two 15 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. The 15th piece of data and the 16th piece of data. So the median will fall somewhere between those two. What's halfway between 14 and 14? Well, 4 and 4. It's just 4. Okay, so if you've got an odd number of data pieces, it'll be one number. If you've got an even amount, it'll be halfway between two numbers, which is what's happened in this case. So just be careful of that. So we found our median is 4. Now we want to find the average, or the mean as they've called it here. So I'm just going to change my coloured pen, so I can colour coordinate this ish. And how I'm going to find the mean is I'm going to add all the numbers together. So I'm going to go 2 plus 4 plus 6 plus 6 plus 4 plus 3 plus 4. I've done that for us because it took a bit of time. So I'm going to use a symbol here that means sigma, which means everything all added up. And everything all added up equals 131. So to find the mean, we're going to go 131 divided by how many pieces of data there are. So there's 30. So 131 divided by 30. I'm just doing this on my calculator. And it's 4.36. So my mean is 4.36 recurring. So the 6's keep going. Okay, the mode is the one that appears the most. Let me change pens again. The one that appears the most. So we've got 3 2s, 1, 2, 3, 4, 5 3s, 1, 2, 3, 4, 5, 6, 7, 8, 9 4s. So the mode is going to be 4. So the mode is the one that appears the most. And the range, which is the last one, is the distance between the two, the highest and the lowest. So the highest is 8. Take away the lowest, which is 2. Therefore, the range, 8 minus 2 is 6. Okay, so there's a couple of quick ones in there and there's a couple that take a while. So the median one, you've got a bit of work to do to get the median. I normally do that one first because then it makes finding the mode a lot easier because they're all grouped together. And you can also check your mean calculation. So mean and median take a little bit of time. Range and mode are quite easy to do. Now what we're going to do is have a look at what is called a frequency table or a frequency distribution table. I've got a couple of examples here. They look a little bit different. This one up here has number of marks, tally as you go, and how often they occur, so frequency. So that's pretty typical of what you see. You might also see something like this down here, where you'll see that instead of marks, it's got classes, which means that this data here falls somewhere between 20 and 30. And these 8 pieces of data fall somewhere between 30 and 40. So they've used groups there instead of individual data pieces. And it takes a bit of getting used to which one you'd use where. I'll show you a couple of examples in a minute. But if you're going to end up with, say, 20 rows, you're better off using groups. Okay, because if you've got a frequency distribution table with 100 rows, it loses its meaning a little bit. You might as well just write out the numbers. So you can see all of these start from the lowest number and go all the way through. You can't go 1, 4, 7, 9. You've got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So you've got to go all the way through from the lowest value to the highest value. And here's another example of a grouped one that goes from 45 to 99. Okay, so 2 types. It could be grouped or it could be ungrouped. So we're going to do an example with ungrouped data first of all. And I've actually done it for you because it does take a little bit of time, and I'll show you on the next one how to do it step by step. But the first thing that I check is the highest number, which in this case is, I can see a 7, I can see an 8, so 8 is the highest, and the lowest number, which is 2. Okay, so my frequency distribution table has to start at 2 and it has to go up each one until we get to 8. Even if there's no 7s, if there's no 3s, you've got to go all the way up. So that's not too many categories, so I can do it as ungrouped data. If the highest was say 100, 2 to 100, I'd be going for group data because otherwise I'm going to end up with too many rows here. So if we head over to the frequency distribution table, we can see our lowest one of 2 is there, and it goes all the way up one by one all the way to 8. And what they've done is they've made a tally, which means that they'll go through, they'll find a 2, they'll cross it off, they'll put a mark. They'll find another 2, they'll cross it off, put a mark. Find another 2, cross it off, put a mark. Okay, and then once you've finished crossing off all the data, you count up how many marks you've got, which is 3. Once all those are done, you count up your frequency here. You can see this little sigma sign again. That means sum. So sum of all the frequencies added up is 30, which is what we want because our question says that there are 30 students. So not too hard. The next one's going to get a little bit harder. So if you want to pause on this and maybe make your own frequency distribution table out of this data, that wouldn't be a bad idea. So this next one, I'm going to do much the same and I'm going to use the same kind of thinking. So my highest number here is, I can see 29, that's pretty high. Yeah, so the highest one is 29. And the lowest number, I've got a 7 there, 6, 5.8, It's looking like 5.8. Okay, so this is decimals, which makes it harder again. So if I wanted to go individual ungrouped data, I would have to go 5.8, 5.9, 6.0, 6.1, 6.2, 6.3, 6.4, all the way up to 29. So you can imagine how much data that's going to be. So I'm going to group it. And what I might do is I might go in groups of, if I go in groups of 10, I'm only going to have 3 groups. I'm going to go in groups of 5. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. Okay, 1, 2, 3, 4, 5, 6. Okay, and this one here is going to be empty, but I'm going to leave it in, oh no, sorry, I've got a 5 here as well. Okay, so what I want to show you just before we start is these little less than symbols. Okay, so what I'm saying there is if it's less than 5 but more than 0, it's going to go in the first category. If it's less than 10 but greater than 5, it's going to go in there. That solves a lot of problems, especially when you get something like a 5. I saw somewhere, I swear. And you go, oh, which one does it go in? It goes in that second one. So 5 up to 10, but not including 10. And that one is anything less than 5. So you could get 4.9 in that group, but 5's got to go in the next one. Okay, so I'm pretty happy with my groups here. I've checked that everything fits in them. And there's not too many, there's only 6. So I'm going to put them in the class one here. So 0 and less than 5. Above 5 but less than 10, above 10 but less than 15, above 15 but less than 20, above 20 but less than 25, above 25 but less than 30, and that's it. Okay, so we can see a couple of other things here. Midpoint, tally, and frequency. We've seen tally and frequency in the last slide. Midpoint is new. Okay, midpoint is halfway in the middle of the class. So in this case, the midpoint would be 2.5. For this one, it would be 7.5, 12.5, 17.5, 22.5, and 27.5. And the reason we do that is that if we need to find the mean, the median, those kind of things, it's really hard to do when it's in a group because we don't know if these are all zeros, if they're all 5s, if they're a mix. So we use the midpoint to calculate that data, and we're just saying that everything that falls in this group, we're just going to count it as 2.5. Okay, so let's start putting some data in here. So I'm going to have a look at things between 0 and 5, which I don't think from memory there's any in here. Nope, none in there. Between 5 and 10. Actually, what I'm going to do, I'm going to go through one at a time. And if you want to speed this up, you can. So 10.3, there's one there. 13, there's one there. 7.1 goes in there. 12.4 goes in there. 16 goes in there. 11 goes in there. 6. Okay, 1, 2, skip a few, 99, 100. So I've just paused that and done those, and now I'm tallying up my tallies. So I've counted them all, and now I'm going to check that I have 40 pieces of data in there. So I'm being a bit lazy and just doing this on my calculator. Yep, and I've got 40, which means that I've got all my data in there nice and accurately. Okay, so that's a frequency distribution table. That one is grouped, and the one we looked at before is ungrouped. And to tell which one you're going to do, you're going to have a look at the highest and lowest values. And if you've got any more than about 7 or 8 groups, 7 or 8 rows, you're going to group it. Okay, so that is our frequency distribution tables. We're going to have a look at another way of displaying data, which is the stem and leaf plots. Okay, so stem and leaf plots only work for numerical data, which means that it has to be numbers. So those frequency distribution tables can be anything. It could be number of cats, dogs, addresses, whatever. The stem and leaf plots need to be, they need to be numbers. So there's a couple of points to know about stem and leaf plots. The stem here gives you the core value and the leaf gives you kind of the other digit. And the key, which is down here, is the most important part of a stem and leaf plot. If you don't put a key in, it doesn't give the stem and leaf plot any meaning whatsoever. So here you can see that 6-3 is 63 years old. So here the 6 and the 3, that's 63 years old. This here with the 6 would be 66 years. This would be 40 years. This would be 27 years. This would be 1 year, 4 years, 10 years, 27. Okay, so if you can read a stem and leaf plot, you might be able to draw one based off that as well. Important things to note, they go from lowest to highest, which means they go in ascending order, the leaves. So they start off next to the stem quite low and they build their way up. If you have a 0, you have to put it in. So like 10, you've got to put the 0 in there, otherwise it doesn't make sense. So we're going to have a look at another one. This one down here has a class A and a class B, and they've collected that data and they've put it into separate stem and leaf plots. What we're going to do today is we're going to put them in what's called a back-to-back stem and leaf plot. So I'm going to do that on this page here. So I'm going to rule up my back-to-back stem and leaf plot. Okay, my stem goes down the middle, so 4, 5, 6, 7, 8, 9, 10. I've got, I'll make this one class B, and this one can be class A. Okay, and then it's exactly the same. So here we've got 9, we've got 5 and 7, we've got 6, 6, 8. We've got 2, 8, 8, 8. Yours is going to be a lot neater than mine. Okay, and going off the other side, we've got 2 and 7. We've got 2, 5, 8, 8. Okay, so you can represent data on individual stem and leaf plots, or you can represent them on back-to-back stem and leaf plots. So I've got a couple of examples here. I'm not going to do them. I will get you started, but I would like you to do these ones. So these scores represent the distance in kilometres travelled by a group of people over a particular weekend. So it's kind of similar to the distribution table. I'm going to look for the lowest one, which I reckon is there, 2. And I'm also going to look for the highest one, which looks to be 105. Okay, so we need to figure out what we're going to put as a stem and what we are going to put as a leaf. And I imagine I would put my stem as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with my key being 10-5 is 105. Okay, so something like 2 would go up here, 34 would go here, 63 would go here. Okay, so I'm putting them kind of the tens in the stem and the units as the leaves. If you want to do it that way, try and get it into ascending order to start with, otherwise you're going to have to draw another stem and leaf plot and put it in ascending order. Right, so if you want to have a go at that, you can pause it and finish it off. The other one we're going to look at is a back-to-back stem and leaf plot. So these are percentages on a maths test. So I'm going to put my stem down the middle. Again, I'm not going to do it for you. You can finish it off yourself. 9A, 9B. I'm going to have a look at the lowest score, which looks to be 32, and the highest one, which looks like 96. Okay, and I'm going to think of a key because the key is the most important part to stem and leaf. So I might make the tens again like this, 32%. So 3, 4, 5, 6, 7, 8, 9, 10. So all of 9A is going to go over here. Okay, if you want to only do it once, you have to put it in order. Okay, and all of B is over here, and fill it in. Okay, so those are the stem and leaf plots. The last thing we're going to look at is just go through a review of different ways to display data. So we've just looked at the stem and leaf plot. These are ones that you should have seen in grade 7 and grade 8. So we've got bar graphs. So they're bars coming up here. We've got pie graphs, which you would have seen in your assignments. We've got histograms, which is like a bar graph but no gaps between the columns. And we've got a frequency polygon, which is the line that connects up the histogram. Okay, we're going to have a special look at the histograms because that is part of the Year 9 curriculum. The other ones, just be aware that there are other ways to display data. So the histogram, we've got an example here. You can see that, say for results, 3 people got a 1. Okay, so the frequency, it occurs 3 times, 3 people got a 1. How many people got a 3? 11 people got a 3. Okay, so you can see very quickly from this, the most common thing was a 3. The least common would be a 7 or a 10. And you can see that most of the results fall around this area here, so you'd think your average would be in there somewhere as well. So histograms have a couple of things that you need to make sure go in there. The first thing is an appropriate title. This one is not an appropriate title because it tells us absolutely nothing about the graph. Okay, so a appropriate title would be something like goals kicked per football game. Okay, or something that gives the data meaning. Along the same lines, the x-axis, which is this one down here, needs to be labelled in a way that helps. The user should be able to look at the graph and know exactly what it means without having to ask anyone. So along the same example, if you had the title of number of goals kicked per football game, you could have this axis titled number of goals kicked. Okay. It also needs the y-axis labelled, which is this one up here. 99.99% of the time, labelling it frequency will get you out of it. Okay, so this is just how often it occurs. Another little thing you need to watch out for, it needs a gap at the start and a gap at the end, and that gap's normally about half the width of a column. Okay, so let's bring all that together and actually use it. This one here, you might recognise this from earlier on in this video. It's the 30 students and how many families they got at home. So we've taken the data and we've put it into a frequency distribution table, and then we're going to turn it into a histogram. And that's normally the order of things you'll be asked to put it in frequency table and then into histogram. So this is a bit harder for me. I can't put a ruler on my screen because it messes it, but I will try and do it as neat as possible, but you should definitely be ruling this. So what I'm going to do, I'm going to decide what my x-axis is going to represent, and that's going to be number of members in the family. So it's going to start at 2, 3, 4, 5, 6, 7, 8. I'm going to make my line a bit shorter so it looks like I meant to do that. And that is number of families, number of members, family members. Okay. And I'm going to label this way as well. The highest was 9 frequency, so I'm going to go all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, I'm going to label it frequency. If you just get into the habit of calling that frequency, you'll be pretty all right. Okay, we need another thing. We need an overall title, and I'm going to reread the question to get this. Number of people in families. Okay, so there's a bit of flexibility with that one. Just make sure it says something useful and it tells you what the graph is about. So I'm going to first start off with number of family members 2. This occurs 3 times. So I'm going to go up to the 3 and put a column up to the 3. You know the same thing, 3 family members occurred 5 times. I'm going to go up to the 5. 4 family members occurred 9 times. So I'm going to go up to the 9. 7. 6 family members occurred 4 times. 7 family members occurred once, as did 8 family members. Okay, and that's my histogram. So gap at the front, gap at the end, my axes are labelled, and I've got a title, so I'm all done. Okay, and that comes to the end of our little statistics unit. That's everything that we're going to cover in our test, as well as a little bit extra just to keep you awake. And it might also help with your assignments. So let me know if you've got any questions about it. Otherwise, good luck.